So I was finishing up the Harry Potter series. I was reading all of the books and watching all of the movies. And naturally, when I finished, I thought to myself, I want a wand. And I know it needs to be magical, and given that electricity is basically magic, I got to work. So there's a lot of cool videos out there of Harry Potter wands, and I've settled on a couple of ideas. Lumos and Nox will be turning on and off an LED at the end of the wand. I think this should be pretty straightforward. Incendio will be shooting a fireball, similar to these videos here. I think I have an idea of how this works, but we'll talk about that later. And then potentially Avada Kedavra I might implement, which would be like a high voltage module. In addition to these spells, I want it to be voice activated, fully encapsulated, and relatively wand sized. So with all that out of the way, let's take a look at what the system view will look like for this wand. So here I break down all the wand's features into blocks. This kind of just helps me see from a high level point of view, like what will be all the processes that happen in the wand. Ideally, I would go through each one of these smaller sub blocks and brainstorm different ideas and then kind of pick the ones that I think would be the best for the first prototype. I kind of have an idea of what I'm thinking, so let's kind of go into each thing for this wand. For recording audio and processing that audio, I found this like speech recognition module V3. I think it's from Electhouse. This works really well with Arduino. It allows me to use custom commands, so I can actually train it with any word I want, and then it will activate any of the digital output pins that I program in the Arduino. Once you kind of figure out how to connect the voice to the Arduino, I feel like from here the sky's the limit. Really nice too is with this module, it comes with a library where you can add any of the programming you want to work with it, and that will be for that block. For the switch, I'm thinking just a couple of 5-volt relays. I had to make sure that the coil current was really low so that the Arduino could close the circuit completely. I'm going to use probably 2 to 3 of these relays, so it'll be 2 to 3 of these digital output pins from the Arduino, and then that'll close the circuit for all the 3 spells. For the heating element, I think I saw somewhere that they used nichrome. I'll have all these parts down below, but here's a picture of what that kind of looks like. It's really thin wire, and it heats up really quickly when you put a voltage across it, supposedly. And so what I'm thinking about this is, this will be at the bottom of a copper tube, and then I'll kind of seal off the bottom after connecting the positive and negative leads. So when the circuit turns on, it'll have a high current going through this heating element, it'll heat up, light the flash paper that'll exist in the bottom of the tube, and that kind of high pressure buildup when it lights will force it out of the tube, creating that fireball. So I hope that's how it works. That's kind of what it looks like from the videos I've seen, and we'll try that out, see if it works. For the LED, you might have saw from the beginning of this video that there was a reel of the LED strips, like, you know, those like programmable ones, like the ones you can push the buttons and get the different colors. I tried using that, thinking I could cut it up and then maybe just use blue, so I wouldn't have to like kind of do anything new to the circuit and then wire that around the tube. But that proved really difficult because you kind of had to like really cut it near the LED and then like solder it together, and it was a whole mess. So I found this really nice bendy LED that Adafruit had, and it's really small, it can wrap it around the tube, so it should work just fine. And for the power source, originally I was thinking a 9-volt battery, and shortly after kind of putting that together, I realized the heating element needs a lot of current to heat up, a lot of power to heat up. And I saw that the 9-volt battery wouldn't be able to heat up the element in the way that a lithium-ion battery would be able to. I switched to an 18650, but the 18650 comes with its unique set of problems because I'm going to a battery that's a little bit bigger. It's also 3.7 volts, so that won't be able to power on the Arduino Nano. So I had to get an additional boost converter that will step up that 3.7 volts to 9 so that the Arduino can operate. So there'll be like 2 separate circuits that are going on. There will be the Arduino that's powered off of the boost converter with the speech module, and then there's the other circuits that go through the relays, which initiate each circuit. And lastly, Avada Kedavra, I'm thinking about using these high voltage modules that you can find on Amazon. I think they're the ones that are in fly swatters, like the electric fly swatters, and so there's no way those can harm me, right? And so given all the final choices for the parts, here's kind of what the schematic looks like of everything put together. You can see the Arduino kind of has its own separate ground that connects with the speech module, and then the ground and digital output pin goes to the relays, but it's separated from the 18650 battery, which that power is able to drive all of the different circuits that we want to use for the spells. So with that, we have the circuit diagram, all the parts picked out. So before actually making the wand, I wanted to create a kind of tabletop model showcasing all the wires and everything connecting together. It will also offer an opportunity to test it, see if anything goes wrong. So the next videos you'll see will be me putting together the model and seeing how that turns out. So this is the model I had in mind for the wand. I'm thinking about laying all the spells on the right side and then all the different processing and things on the left side. On the right, you'll also have these two kind of coverings where you can still see the spell as you initiate it, but it's all protected. And then on the left, we'll have a display plugged into the Arduino so that you can see the commands as they happen. I also want to have these little labels here kind of propped up where you can see, oh, okay, this is the Lumos one, and then here is that part of the circuit that is that spell. I think this will be a good layout. We've already talked about all the different parts, so I'm going to test some of the components over here first, and then begin building the model.
Incendio. Incendio. So now it's trained. So now, I think I just do load one. So now it's loaded. So now I can go Incendio. And boom, now it pops up. Incendio. 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 There it is. Okay, I just have to say it in a really specific way, which is, I want to be able to yell it. I feel like that's what I want to do. If I could just be like, Incendio, and then, oh, okay, there it is. I guess, okay, maybe it is going to do it for me. I don't know. It's just kind of goofy. So yeah, that's basically how it works. It recognizes I'm saying the spell and then it's lighting it up. So that's cool. Maybe I can get the Lumos to work too. Lumos. Hey, so now it's showing it here. So now if I go Nox. Oh, no. Nox. Nox. There we go. Okay, so I have to say it with confidence. That's the key. I think we're learning here. But that's that. So now, that's step one, was figuring out, recording it, Arduino is going to handle it, now it needs to initiate an action. So we've done it with LEDs, we know it can work with LEDs, now we need to get it to light something on fire and light up LEDs around the tip of the wand.
After that, I created the Incendio part of the wand. I put the nichrome wire at the end of the copper tube, and then I sealed it off with some hot glue. And then I set up the Arduino, I soldered on the headers, and then I began soldering in the 3-switch circuit when I filmed this moment. Oh, I look ridiculous now that I pull up my camera. This freaking thing took so long, but it's complete. I just have to add the power leads and stuff to it. But oh my gosh, it took so long, and I just measured all the different continuities and whatnot, and it is good. It did work, but goodness. After those parts were complete, I went to Home Depot and picked up, cut, and painted these pieces of wood. These will be used to hold up the components and their names. I just continued to glue the components to the model as I painted around it. I also bought these glass jars to put over Incendio and Avada Kedavra to prevent anyone from touching it directly. Here, the model is almost complete. It has most of the parts set up with their name tag, and then a little bit later, this happened. Ladies and gentlemen, we have done it. I'm going to demo 2 of them right now. 2 of the spells. So first we have Lumos. Perfect. Voice activated. Nox. Okay, there we go. Now the next one we have is in this glass jar. That is Avada Kedavra. And all these are voice activated. Okay, and very sensitive. As you can see. The last one I'll show later. And there goes Lumos. I also forgot to mention, for the model I included Avada Kedavra, but later you'll see that only Incendio and Lumos will be in like the same wand. And voila, here's the full model put together. And while it was a bit finicky in the moment, it recorded its first full test. Of a voice-activated Harry Potter wand. Lumos. Nox. Nox. Avada Kedavra. Incendio. Here we go. Now we entered the last phase of the project, fitting it all in a wand. And before we continue, I just want to say that the model along with the finished wand will also be with me at OPENSAUCE 2024. So super excited to say that, but there'll be more details at the end of the video, and I'll also put some things in the description in case you just want to learn more about OPENSAUCE. So here's the original game plan of the wand. I actually drew this to scale. I've traced every part in this drawing. And my brain thought it'd be a good idea to lay each part out head to toe, putting the widest parts in the back of the wand and then the more narrow ones in the front. It seemed nice because I wanted the microphone to be in the back and the speech module was the widest part. So I figured they're right next to each other, might be kind of nice. I also gave a good margin between the parts and the outside of the wand so that it wouldn't be too thin. And then I also wanted to put a hole in the back of the wand where the microphone would kind of pop out. Now this model includes the high voltage circuit, and I point that out because foreshadowing, but it makes it a pretty big wand, and it's around 14.5 inches in length and around 2 inches at the handle. When I first learned about those numbers, I thought that seemed like a reasonable wand shape, but you'll just have to be the judge of that. I know what you're thinking. You went with this design. It could be improved, but surely you're not going to make the first prototype out of wood, because that would be a nightmare if you were to mess up, and then you had to buy more wood and cut that down, and it would just be so much easier to 3D print. Well, so I drove to Home Depot and I purchased a block of wood, not even a cylindrical one, because that would make too much sense, and I started drawing out my cuts. I then went to my local makerspace, cut the wood to shape, and carved it into a cylindrical shape. And then after that was to my liking, I cut it in half so I could begin hollowing out to the dimensions of the plan in the wand. And you see why this is getting a little bit more hectic. I think what my brain thought was, oh, wands are made out of wood, so that's what it's gotta be. I gotta make the wand a wooden wand. But I don't own any of the tools that you see me using, the Dremel, the saw. I did buy a chisel, but I had to work with the hours of the makerspace that I was going to, and I work full time, and it was just becoming impossible to do it out of wood. So after about 2 hours of dremeling out the nozzle for the copper tube, I was sick and tired of coordinating the tools with the makerspace hours that I gave up on the wooden one and went to designing it in Fusion 360. Now, I didn't really use 3D design software in school, but let me tell you, Fusion 360, pretty nice. I saw that you didn't need a license for it, but it works great. I honestly was able to pick it up and ended up designing the wand to its full dimensions in one night and then began printing it. The print took a while because I had to cut it in a bunch of different slices in order to fit it into the wand, so I actually had to print it in 4 different pieces. So here is the model of the wand. You can see all the different grooves for the parts that we talked about in the plan. And then here, I actually used a heat gun to melt the 2 parts together. So I printed this part on the 3D printer and then this one on the 3D printer and then put it together. And here's the other half. And you can see, just compared to my head, it's freaking big. And when they're together, which was how it was originally designed, looks crazy, right? Imagine holding this as the freaking wand. It's crazy. And so I saw this when I finished printing, and I was like, this has got to be improved a little bit. There's no way I'm making this the final prototype. Might have saw it in the wand section of this video. I put V1 and V2. There may even be a V3. This was improved. Kinda big. So I figured for version 2 of the wand, I would cut out the high voltage circuit because it's too much trying to fit the wires on the outside of this copper tube, and it takes up a good amount of length. Then I would try to move the speech module underneath the lithium ion pack because it's also PCB, it's pretty flat, and it doesn't sacrifice a whole lot of extra width here. Then I'd also make the microphone external. That way I could plug in a shorter mic, I can plug in a long mic or a headset, kind of like this one. It just makes it interchangeable. So it's like this whole distance is now gone, and this distance is now gone. Really, it's just this part, and the nozzle. So I got back to designing the wand again in Fusion 360. After a couple of iterations, I landed on this model here. And as you can see, it is a huge reduction from the other wand. And really all I did this time was I fit the 3D model around each part. So before, I kind of created the wand's overall shape and then created cuts for each part. This I worked the other way around. So I actually started with the shape itself and then built the model around it. And that way it was like the slimmest it could possibly be. And then I gave her just a margin of around 2 millimeters, I think. I might have done a little bit more than that. So it came out really slim. And I was really proud of it. Thought it was like a really big reduction, but like we talked about, a lot of that came with removing the high voltage module and then fitting all the PCBs around the battery. And the last step was to wire together all the parts and fit it in the wand. So I started making another switch module and then making another heating element, wiring all of that to the PCBs and then to the battery slot. And then after go and after go and after go, it was complete. Lumos. Knox. Incendio. Oh my gosh. Let's see how far it can shoot. Incendio. Wow. Holy cow. Lumos. Hey, man, this thing looks great. Knox. Nice. If you've made it this far, thank you guys so much for watching. If you want to find more content like this, subscribe and go check out my website for more details on the wand. Thanks. Incendio. Ooh. Didn't really shoot out.